So now for the science, we're looking at primary, secondary, and tertiary alcohols and naming alcohols. So now we're going to look at alcohols. Alcohols contain a hydroxyl group, which is an OH group, somewhere in the chain. Alcohol is important because they're fuels, they can be used to dissolve things, and they're also found in your body. Occasionally they're added to drinks as well. So science understanding we're going to look at. Alcohols are classified as primary, secondary, and tertiary, and identify, name systematically, and draw alcohols containing up to 8 carbon atoms in the main chain with 2 side chains, and 1 or more hydroxyl groups. Let's start by looking at primary, secondary, and tertiary alcohols. So what do we mean by that? So a primary alcohol, the hydroxyl group is attached to a carbon that's attached to one other carbon, or in the case of methanol, a hydrogen. So when we're looking at primary, we're talking about how many carbons the carbon that's attached to the hydroxyl group is attached to. That sounds confusing, but what you do is you look at the hydroxyl group, you look at the carbon, and you see what it is attached to. If it's attached to another carbon, that makes it primary. If it's attached to 2 carbons, that would make it secondary. If it's attached to 3 carbons, that makes it tertiary. So, primary alcohol. So, an example of a primary alcohol is this one here. So, we've got 1, 2, 3, 4 carbons. So, methyl ethyl propylbutanol butanol, and butan-1-ol, because the hydroxyl group is on carbon 1. So, that's a primary alcohol. The hydroxyl group here is attached to a carbon that's attached to 1 carbon, so that makes it primary. The secondary alcohol, that's where your hydroxyl group is attached to a carbon that's attached to 2 carbons. So here's my hydroxyl group, making it an alcohol. Here's the carbon that the hydroxyl group is attached to, and that's attached to 2 carbons, and a hydrogen as well in this case. So, a good example of a secondary alcohol is this one here. So this is butanol like we had before, but now it's butan-2-ol because the hydroxyl group is on carbon 2. So the hydroxyl group is attached to a carbon that's attached to 2 carbons. So that makes it a secondary alcohol. So in a tertiary alcohol, the hydroxyl group is attached to a carbon that's attached to 3 carbons. So here we've got 3 carbon chains, R1, R2, R3. This is the hydroxyl group that makes it an alcohol. It's attached to a carbon that itself is attached to 3 carbons. So 1, 2, 3. So an example of a tertiary alcohol is this one here. So 1, 2, 3, 4. So the longest chain though is a 3. So this is 2-methyl propan-2-ol, or methyl propan-2-ol. There's only one place that can go. So 2-methyl propan-2-ol. So if we look at the hydroxyl group, it's attached to a carbon that is attached to 3 carbons, 1, 2, 3. So that's a tertiary alcohol. So naming alcohols, we get rid of the E at the end of your parent chain and replace that with ol. We put an infix telling us what carbon the hydroxyl group is attached to. And if there are 2 or more, we use di, tri, tetra, and so on. So we'll do some examples here first. So let's look at this one here. So find our longest chain, and we're going to number so that the hydroxyl group is on the lowest number. So we're going to number from this end. So 1, 2, 3, 4, 5, 6, 7. So 7 is hept. Alright, what carbon is the hydroxyl group on? Carbon 2. So heptan 2 for the infix, that tells us what carbon this is on, and ol at the end. So heptan-2-ol. Sometimes this is hept-2-ol. I prefer to put the an in. If we look at this one down here, we're going to number again from this end, so that'll give us our lowest numbers. So 1, 2, 3, 4, 5, 6. There we go. Alright. So it's hexan. So hexan. Now we've got a hydroxyl group on carbon 1 and carbon 3. So hexan 1, 3. So because there's 2 hydroxyl groups, we call that a diol. So hexan 1,3-diol. So now we're going to do some examples with alcohols. So let's start with this one down here. So 1, 2, 3. So 1, 2, 3. So 3 carbons. So methyl ethyl propan. So propan. Our hydroxyl group is on carbon 2. 2, and our suffix is ol. Look at this one here, there's no carbon here, so we start numbering from there. So 1, 2, 3. I could call this one 3 if I wanted to, it doesn't make a difference. So again, we've got a propan, and the hydroxyl group is on carbon 1, so propan 1 ol, but we've got this methyl side chain here. So, and that's on carbon 2, so 2 methyl propan 1 ol. Last one down here, let's have a look. How many carbons in the chain? So 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to name this one over here, so it's going to be, we have non somewhere. So our hydroxyl groups are on carbon 1 and carbon 3. So non and 1, 3, we've got 2 hydroxyl groups, so diol. Alright, now we're going to draw some, so start with the pentan bit. So 1, 2, 3, 4, 5, and on carbon 3 we've got our hydroxyl group. Then you fill in the rest of your H's. This one here, 2-methyl-octan 3-ol, so we're going to start with the octan bit. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. On carbon 2 we've got a methyl group. And carbon 3 we've got our hydroxyl group. Lastly, we're going to do hexane 2,3-diol. So start with the hexane bit. So 1, 2, 3, 4, 5, 6. On carbon 2, I've got a hydroxyl group. On carbon 3, I've got a hydroxyl group. So that's how you name alkenes, alkynes, haloalkanes, alcohols. So in Flippin science, we looked at primary, secondary, tertiary alcohols and how to name them. That's it for the class today. See ya.